all right. I'm not muted. Perfect. Okay. So sine 3 pi over 2. If you look at the, and I know you guys done this already. I'm just doing it again. So 3 pi over 2 is down here, obviously. And you want sine of 3 pi over 2. So you want the y coordinate. What's the y coordinate at 3 pi over 2? Thank you, Diana. -1. So what this means, you're going to do the inverse sine of -1. Okay. Now, inverse sine of -1, this means that's going to equal theta. So theta equals, sorry. So sine theta equals -1. However, it's inverse trig with a default range. Bless you. Our default range for inverse sine is from -9 to 90. Now, let's go back to the unit circle one more time. Where is, if we want inverse sine of -1, inverse sine -1, you want the y coordinate to be -1. Where's the y coordinate -1 on the inner circle? Back to the same place. But you're not going to say 270. What are you going to say instead? -90. Thank you, Ella. -90 because you have to go this direction. So coming back again, doing this one more time. This right here equals -1. So you have inverse sine of -1, which equals theta. So theta is going to equal -90 degrees. Let's try this again for 15. What's sine pi?
0.
Good. And then what's inverse sine of 0? That's going to equal theta. So where is the y coordinate 0 in the unit circle? In two places, actually. At 0 and 180. But what's my default range for inverse sine? So what I'm going to say 0, 180. 0. Thank you, Ella. You're on fire today. Good. Exactly. 0 degrees. Okay. Oh, these notes? Oh, sorry about that. Let's update right now. Actually, I was so focused on algebra 2 this morning, so I neglected you guys. It's my fault. Hold on. Lecture notes. No, it's right. It's right there. 4.7 notes. Walton's there. You need the 4.8 notes, though. Let me add that really fast. One sec. Okay. Yes. No, I don't think so. I don't think so. Okay, sorry about that, guys. Let's keep moving. All right. Okay, so guys, next one. Guys, let's keep moving. I got a little distracted there at the uploading of notes. All right, so next up, inverse cosine -1. That's supposed to equal theta. So you want the x coordinate. At what angle is the x coordinate -1, guys? 180. Thank you, Dan. 180. So now you want cosine 180. Well, what's cosine 180? Back to -1. Yep. And sometimes it might be the same.
See, these were not like, even though these knocked each other out, the answer was 0 instead. When these knocked each other out, the answer was -9 instead. But these didn't knock each other out, and the answer was -1. Sometimes the input and the output will be the same
when you're doing these composites. Just depends on the default range that you have to work with. Okay, lastly, 17 before we do 18 to 20. Okay, inverse tan of 1. So you want y over x to equal 1. And remember, this is theta, right? So tan theta has to equal. Where does that happen? Where's y over x going to be 1 in the inner circle? Thank you, Eric. Very good. Now, what's cosine of 45? Thank you, Connor. You guys are doing great. Root 2 over 2. Perfect. Good. Great. Okay, questions about those 4. Okay. Now let's move on to the last 3. Examples 18, 19, 20. These are a little strange, but once you get a hang of it, it's not that bad. It's not that bad once you get a hang of it. Okay. So let's look at example 18. So again, this is going to be an angle. So theta equals inverse tan . However, 5/12 is not on, guys, quiet please. It's not on the unit circle. 5/12 is not on the unit circle.
So that's going to be kind of an issue, but we'll have a workaround. So you're asking to inverse tan 5/12. Again, I can't find 5/12 in this one. So here's what you're going to do instead. You're going to actually just understand what we're doing.
So we're going to draw a triangle like this. What does this mean? This means that tan theta equals 5/12. Okay, that means tan theta equals 5/12. So I'm going to put theta right here, 5 right here, and 12 right there. This is the part where people get lost. So please ask questions if you don't follow what I just did.
So again, this has to be an angle, this inverse trig, right? Inverse trig is always angles, just so you know. So this is not an angle. 5/12 is not an angle. 5/12 is the ratio of sides, right? It's inverse. The output for inverse trig is an angle. The input is the ratio of sides. If there's tangent, then of course the input's the angle and the output's the ratio of sides. This is reverse. Inverse trig. So the inverse tan is an angle. This is an angle, right? So that's why I do this. So the tangent theta is 5 over 12. Remember, the 5 is the O, 12 is the A, opposite over adjacent. Does that make sense? Like construct this triangle? If you understand 5/12, exactly. Or in this case, opposite over adjacent. Right? Over it.
Or if you put on a coordinate plane, you could do that too, which actually I'll do for one of our examples. You can totally do that too. That's totally fine. So how am I going to find the hypotenuse? How do I do that? Yep. You get 169, I would square 169, that's going to be 13. So that's 13. Now, final thing we have to do, finish the problem off. I want the cosine of theta. Well, what's cosine of this triangle I just drew? Over. There we go. That's the answer. I know I did quite a bit of work. This will be faster once I do the other examples.
But what I'm doing is constructing a triangle based on this. It's unput and restrict. Once I construct a triangle, then I'm actually going to go through.
This is 4.7 still. 4.7. So again, what I just did, this is theta. So theta equal inverse tan of 5/12. So tan theta equals 5/12. Drew a triangle. Theta, 5, 12. Did Pythagorean theorem, got 13. Found cosine theta, which is 12 over 13. That's really the work you need to show. I know I added a lot of stuff earlier on, but that's really the work you need to show. So let's try again for example 19. Okay, this is theta. Theta equals inverse tan of 3/4. So what does tan theta equal? 3/4, right? Draw a triangle. Theta, 3 and 4. So far, before I go any further, are you guys with me? We're good?
Yeah.
Okay, good. Now,
What's my hypotenuse? 5, right? Hypotenuse is 5.
so therefore, I want sine theta, which is 3/5. Not that hard. But we're okay with 19? We're okay? All right. Example 20. Again, this is theta. So sine theta equals -1/3. Now it's negative. That one's kind of weird. So I'm going to actually draw a coordinate plane and put this in the 4th quadrant. Okay, because sine theta is negative. Where am I going to put the -1 and 3? Remember that's opposite. That's hypotenuse. So where's the -1 go? The vertical side? Where's the 3 go? Hypotenuse. And we'll call it A. What do you get for A when you work it out? Very good. Or 2√2. So now I want the cotangent of theta, which is going to be adjacent over opposite, or x over y. Which I'll give to you, by the way. I gave you in the last test. So what's that going to equal? Yep, 2√2 over -1, which is -2√2. So you'll have plenty of practice on the new homework. This right here, that table, number 18, I'm going to have you guys do because you guys need that practice. Okay, so that's one loose end how to tie up. The last one's going to be the word problem, so I'll get there in a sec. But any questions about 4-7? No? Okay. William, you good?
Wait, will there be word problem for the?
I'm going to do that right now. Yes. I'm going to cover right now. Okay, the last set of notes, so if you guys turn the page, I want you guys to cross off some things first. If you guys can cross this off, where it says bearings, we're not going to do that. Near the end of the notes, where it says bearings, we're not going to do that. Also, you can cross off this entire page as well. Okay. But we are going to do stuff on the last page. And also going to do stuff prior. So let's start over here. We'll see the Eiffel Tower problem. This is just review. Okay, this is a terrible drawing of the Eiffel Tower. I know it's more ornate than this, but that's all right. Okay, so you stand how far from it? You stand 80 feet away.
Oh, we're standing 8. Oh.
And it's 85.4 degrees. Mm-hmm. Here's H. So how would I solve for H, the height of the Eiffel Tower? What would I do? What would I do, guys? You guys should know this. Thank you. Tangent of what? Mm-hmm. N equals opposite or adjacent. Go ahead. Perfect. Thank you. So this is just jogging your memory. The reason why I'm reassessing this, you guys define this. You said how much you guys are prepared. Right? And so this is the reason why I'm kind of bringing this back. So yeah, so there we go. And then that's easy to solve. How would I solve that? Multiply said by 80, exactly. Sure, yeah, go ahead. And we solve for H. I have it in my calculator here. Yeah, all right, got you beat. But thank you. 994.3 feet. That's correct. Thank you, Teo. Okay, pretty easy. Not too hard. Yeah, maybe it's her. All right, that's mean. She's very nice. All right, okay. All right. Let me label this diagram here. Or I'll explain. Okay, let's talk about what I just did.
So you need to label the diagram correctly. Makes sense all this. We told you to stand 800 feet away from Mount Rushmore, so that's why the horizontal leg is 800. That's obvious. There's only two angles of elevation. If you look at the bottom of the Abraham Lincoln space, like maybe this channel, the angle elevation to that is 32 degrees. If you look at to the top of the sculpture, maybe where his head is, or in his forehead, that'd be 35 degrees. So X is going to be that distance using 32 degrees. X plus Y is going to be using the 35 degrees. That's why it rows for two triangles, right? You have a bigger triangle with 35 degrees and X plus Y. You have a smaller triangle with 32 degrees and X 800. Please, 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 please don't focus on the steam triangle here. That does no good. You will learn a formula. Yes, no right angle. We're already going to cover that. It's called law of sines, law of cosine, special formula that we use, which I won't teach you guys every single on November, December. That will enable you to solve for that. But I'm not going to teach that for you guys. That's not part of what we're doing this year. So yeah, good. Sure, yeah, good. All right. So how do I set up my equations now?
How do I set these up, guys? 11th is my last day teaching you guys. Yeah. I know, it's crazy. I know, right? Well, I'm kind of freaking out because I have all these things I have to do to get ready to, like, all these materials I need to create, which I know I'll get done. It's just I'll have some sleepless nights. So, but I'm excited to have the time off. So, totally. Are you kidding me? Of course I am. Yeah.
What?
Yeah, exactly. That's why I've taken the time off. It's called paternity leave. I don't know, it's part of the law. You could. Yeah. No, I'm not gonna be doing nothing. I'm gonna be taking care of my family. Okay, I don't have to. I don't have to show up to my place of employment for 3.5 months, and I still get my benefits. Yeah. Okay, right. Thank you. Okay, and you remember which one I like? But wow. Okay, all right. Okay. You can get it on Wednesday or Friday.
I like to be very organized.
Okay. All right. Okay. Wow.
Major
Okay. So those equations make sense. Tan 32 equals x over 800. And tan of 35 equals x plus y over 800. Do those make sense? Okay. Yeah. So again, all you're doing is SOHCAHTOA, right? You have the small triangle, which is 32 degrees. You have the big one, 35 degrees. You're going to solve for x over here. And I know you guys can do that. That's going to be 499.9 feet. And then over here, you got to do this. And that's going to be, let me go back. 800 times tangent of 35 degrees. Yeah, sorry about that. Bless you.
Thank you so much, guys.
Bless you.
560.2. Okay. So guys, we're okay at that? We're good? Eric, you okay with this?
Yes.
Okay, good. All right. Okay.
Nice and incredible.
Okay. Can we move on? Last problem? Okay, one more problem, guys. So as I said, we're going to cross. So that's all just reviewable. So we had that on the test actually last time. So I haven't said how I'm going to write the question yet. You'll find out on Friday. So again, we cross this off, right? Cross this off here. Also, we cross this off, right? Okay. On the last page. On the last page, cross off example 5. I don't want to do that one with you guys, but we're going to do the one right above it with the one with the spring hanging from the ceiling. So let's cross off that last one. We're only going to focus on this one right here.
This can be on the test.
And there's some practice problems in the review guide.
Wait, where's this?
Right here. It's the last page, Maggie. Last page. Okay.
Sorry.
No worries, you're all good. So here's what the question is asking me to do. It's asking me to write an equation. Now,
For those who are taking physics, probably you guys will do this, or if you're doing physics next year in college. But this is dealing with like vibration oscillations. What happens is if you have a spring and a ball pendulum, you're to lower or pull down on the ball here, the spring here, and let go, they'll go back up and down, right? That's what we'll do. Now, it's kind of like the same thing. You took like one of those like cheap bouncy balls, like those vending machines at a cheap pizza place and bounce up and down. Or, yeah, round table, or if you have a Ferris wheel, that's all this kind of a motion where a Ferris wheel, you know, the bottom and top is up and you go down. So anything that involves kind of springs or rotations, we can model as a sinusoid. So this right here is called sinusoidal modeling. Okay, it's called sinusoidal modeling. What, guys, quiet please. I've got more problem. Thank you. What you're trying to do is you're trying to write a sine or cosine equation that models this motion. So this is I feel kind of one of the more important problems, because a lot of times you do modeling when you're out in the real world using mathematical models to describe something that you're working with, whether it's finance, business, healthcare, or in this case, physics. We want to write an equation that models the situation. So apparently, we have a cosine curve here that does this motion here. And I can put it on a coordinate plane. Good. So here's X. Here's Y. So if you guys forgot, the equation of a cosine function is this. In case you guys forgot. Now, what's my amplitude here? What's the amplitude, guys? What do you guys remember? 4. The amplitude is 4. We're going to say -4 in the answer, amplitude. How about the period? Yes. Now, amplitude is this. Right? That's 4. The period is this. We have some questions regarding the period. Now, the period's like one cycle, right? So see a low point, start at 0. When do we get back to the low point again? What time? What do I get back to your game? Well, so it's repetitive, right? So your period is 6. Now, in case you guys forgot, period is 2 pi over b. If you solve for b, you should get pi over 3.
So
That'd be the b value in the equation. And d is 0 because I didn't move up or down. I didn't shift the graph vertically. So a is going to be -4 because it starts down. B is going to be pi over 3. And d is going to be 0. So final equation will be y equals okay, questions? Oh, sure, yeah, well, yeah. Yeah, it's good. Like one, just have fun. Guys, quiet, please. We're not done yet. Thank you. Please. Thanks. Something similar. The review guide will show you what. So how do I know say work? This starts below the x-axis, right? So it's reflective of the x-axis. That's what I was saying before. Now, once we have the equation, if I ask you, hey, when is the ball going to be at its peak? Can you solve that? Or if I say, like, where's the ball located at t for 10 seconds? I can plug 10 to the equation and get the height after that. So that's the beauty about the models. I can then predict what will happen down the road. So, okay. Really quickly, homework is just going to be this. If you go to Schoology, right here, I'm asking you guys to do a couple things. I'm asking you to complete the table for number 18 of homework 12. So you are going back to homework 12. And then also complete 2, 4, and 6 for number 13. So here's the homework packet.
So you're going to work on this table, number 18. And also, we have 24 minutes left before class is over. And then I just realized these problems here
are mostly hard for you because there's a horizontal shift to these. So they don't start at the origin or the axis. And I didn't cover that with you guys, so I'll have to come up with some other problems, but you guys have more problems.
So I apologize that these problems are not going to work for you guys. But 2, 4, 6, angles of elevation, depression, they're right there. And the review guide, these are some sample problems I put up. I do need to find the answers for these, so I'll get that ready by Wednesday. So let me hand this out to you guys at least, so you guys have that. But the homework is going to be basically school. All right. And you guys can just work, or if you're a little tired, you can take a little break. If you want to finish your homework. And we're already going to check on Wednesday. That'll have one ready, but not today. I mean, when I talk freshmen, like, I think I had like one freshman use that like 2 or 3 times in the period. I think she was by herself. So and it was really, but that's more of like, yeah, that was like that's more security. It's like you're not middle school anymore, like school out a little bit. But you guys are all stalled. And even if you are going to check this out, like that's fine. You need a break anyway, so that's fine. There's something else to write.
Well, actually, I did. I just walked into class.
So you guys have passing day on Saturday?
Yes, sir.
Are they good?
They just
Wow. Okay.
They still there 5 stars. Wide receiver. 6'4", 230. You cover it. You put 2 people in man. You put a. This is what. What?
I mean, you do like a shadow coverage or?
They put a corner on them like 5 yards away, and then they put a safety like 15. And they just ignore everything else.
That's an animal. It's like Monty Adams. If you put Valley.
This guy's ranked highest in the country. This guy's the second best wide receiver in the country.
Jeez. What college do you go to?
Oregon.
Yeah, that's NFL size. It's amazing. That's good. Hopefully he stays for
Yeah.
for your sake.
Hopefully he's injured for 4 years.
Sure. Yeah. You know, funny thing is that Julian Edelman, who's not terribly big, he played for Woodside. Yeah. So.
He wasn't really. He first started with Patriots, he wasn't the top receiver.
Well, Belichick's just like he just knows how to take players, and he definitely made miracles happen.
And I have a presentation for you. Spanish is so much easier than Spanish.
Whoa, Lord, how?
English presentation is good. What Spanish do you start using?
Whoa.
Is it English too?
Oh, oh.